Welcome, everybody. It's great to see many of my friends, long-time friends I've made in recent years, and many, many new colleagues. It's always refreshing to see the diversity of the audience and the fact that it's a good balance of people who have been associated with the program for many years and many new folks who are becoming part of the Unidata community. We have reserved a very nice warm weather, which is very typical of this time of year in Boulder. The temperatures are going to rocket into the mid-90s, but we always say it's dry heat. And that should make you feel better. So you'll find out how dry it is with the relative humidity going well below 10% most afternoons. Anyway, as I get started with the presentation, and as I was putting together this presentation, it was truly a journey through the memory lane for me in particular, as we talk about past, present, and future of Unidata user workshops. The purpose of my talk on this subject was to give you some context about Unidata, evolution in the community, evolution of the program, and all of that reflected in the topics chosen, the formats for these user workshops over the years. And hopefully you'll all get a glimpse of what these users workshop used to be, how they have evolved, and where they will be going with this one and into the future. Before I get started, I'll just give you a quick rundown because many of you are relatively new to Unidata. How many of you are new to the program itself in terms of knowing much about the Unidata program? Just a handful, huh? I thought there would be more people who will be not familiar with the program. Maybe I can quickly run through this slide. We are an NSF-funded cyber infrastructure facility, and we were founded, as Bill Coe mentioned, in 1984, so we have been around for a while. And we have been doing these workshops for a while as a result. What do? We acquire and distribute real-time ecological data. That's the bread and butter of Unidata's mission. We have been doing this from day one, and today we now get about a terabyte of unique data that we receive from many sources, and all of that gets moved to our community of users that are in many different locations worldwide. If we are providing data, it's incumbent upon us to also provide the tools for analyzing, visualizing, managing, all those data. And over the years, we have developed a lot of software within the program, and we have acquired a lot of software from our collaborators and partners in other organizations that we actually provide to our community. If you're providing data and software, you also have to train your users on the use of those data and software. So we provide a lot of workshops and training sessions on the various software and data systems. And we also answer a lot of questions support questions related to the use of our products and services. We also negotiate data agreements and software or tool agreements with other collaborators. Not 100% of the software we provide was developed within the program center, and almost all of the data we get is from other sources, whether that is the National Weather Service, the National Center for Environmental Prediction, other NOAA labs, other Met services in Canada or in the Navy and other countries. So we get data from those sources and we make them available to our users, including data from the private sector. For example, the lightning data that many of our universities get actually is with the private sector, but they are fine giving those data to our academic customers for use in education and research. And we also facilitate the advancement of standards and conventions related to data systems, data models, etc. I'm just going to show you what the atmospheric science, meteorology departments had access to back before Unidata was founded in 1984. This is what a typical state-of-the-art Met lab looked like back in the mid-80s. To the left of me, or to the, you can see the teletypes. These broadcast text information like surface observations, upper air observations, bulletins on watches and warnings and things like that. And on the right, you have the wet paper digital facsimile machines that distributed essentially maps of weather as analyzed by the National Weather Service or satellite images that were provided to Weather Service offices. And the same was made available through teletype telephone lines to universities. And all of this was going away within the Weather Service, and the universities wanted to know how they are going to sustain their access to weather data. And that led to the founding of the Unidata program by the university community, asking UCOR to host the program if it is funded by the National Science Foundation, and it was indeed funded by the National Science Foundation in 1984. And as they say, the rest is history. And this is what it looked like when Unidata came on the scene. Unidata was the first system to bring a computer into the weather lab to receive data and display them and analyze weather data that universities were getting. And this was a typical system that was made available by Unidata if you could afford to buy the personal computer yourself, but all of the data and software was provided to universities. So when universities started receiving those data and had access to these personal computers, the community needed a forum or venue for getting trained. And that was essentially the beginning of Unidata Users Workshop. And these are held every 3 years to introduce new and emerging concepts, tools, data systems, and techniques to the university community. And these workshops are planned and organized by the Unidata Users Committee in collaboration with the program center staff. These workshops should be viewed as a forum for the community to come together to keep up with the advances in the geosciences, geoscience education, information technology topics, and exchange ideas on how best to use our resources in your education and research. And the first workshop was held in 1988 at the iconic I.M. Pei designed Mesa Laboratory that was the seat of the National Center for Atmospheric Research when NCAR was founded, or shortly after NCAR was founded. And I'm pleased to say that I had the privilege of attending that very first workshop back in 1988. And I have attended every single Unidata Users Workshop since then. And I'm probably the only person who has done so, who has been at every one of these. And it's been a true privilege that has shaped my career over the past 3 decades plus. When Unidata was established, Unidata helped to establish a satellite broadcast through which our universities could receive real-time weather data. And the real-time weather data was made available in partnership with the University of Wisconsin Space Science Engineering Center, as well as the National Weather Service, both of which essentially uploaded data via satellite to university use. And if you can read, and it's very blurry and small, but the data rates were, highest data rate was for the satellite images at 9600 baud. And all the others were, that is 9600 bits per second, which you can imagine how fat that pipe was back in those days and how tiny or almost minuscule it is these days. And universities typically established a satellite downlink with those huge dishes that made available those data into their labs. And this data was going to a handful of universities starting around 1986, 87, initially as an experiment, and then it was sustained as an operational data distribution technique. Once the data started coming in, university faculty needed to know how to use these data and integrate them into their classes, into their teaching, student learning, etc. And that essentially led to the very first workshop being held on the topic of how to use these real-time synoptic weather data in a classroom setting and for instruction. As I said before, it was held at the NCAR Mesa Laboratory, and more importantly, it was held in concert with the NCAR Summer Colloquium, which is a marquee summer colloquium or seminar event held over typically 3 to 4 weeks, where distinguished lecturers from all over the world came and spoke on various topics of interest to NCAR and the university community. And this particular year's colloquium was focused on synoptic meteorology advances. And in conjunction with that workshop, Unidata workshop on synoptic meteorology was held on synoptic meteorology instruction, new trends and techniques. And it was actually initially sponsored by NCAR and Unidata. And Bob Gall, who was the lead organizer of that workshop from University of Arizona at that time, made this remark. There are a number of computer systems coming online to display real-time weather data, courtesy of Unidata. The big question I keep hearing is how to start incorporating the new hardware and software in synoptic meteorology classroom. And there were 30 attendees at that particular workshop, and this is the only picture I have from that particular workshop that shows the lab setting. And the lab and the teaching was essentially held alongside of one another. The lectures were given in the main NCAR seminar room, just adjacent to this particular room. Those of you who have been to the NCAR Mesa lab may be able to identify this. This is next to the Damon room up at the Mesa laboratory. And I will give you an extra cookie at break if you can spot me in this particular photo. The only hint I'll give you is that I had a lot more hair than I do now. While this workshop was taking place, the National Weather Service was starting a modernization program. And by modernization program, I mean they were modernizing their observing systems. They were putting together a network of new generation of Doppler radars called WSR-88D, and 88 stands for the year 1988. And they deployed a network of these over the subsequent 4 years called NextRad. And NextRad network was essentially one of the underpinnings of this particular modernization. In complement to the NextRad system, there was also a network of wind profilers, and it was part of a demonstration wind profiler network. It was not quite operational network, but they sustained it for almost 20 years. And that particular network of wind profilers was also going into place. And the Weather Service needed to train their forecasters on the use of all these new data from these instruments and bring them to forecasters and their colleagues in various Weather Service offices. Essentially, in response to this modernization program, the COMET program, about which Bill Coe spoke a few minutes ago, was founded, essentially to train all of the Weather Service forecasters on the use of these systems. And the university faculty wanted to know, how are they going to get trained? If COMET was focused on NWS forecaster instruction, who will be training the academic faculty? And so they had a need and wanted to hold a workshop to learn about these new observing systems and use in education. And that led to the 1991 workshop on synoptic and mesoscale meteorology instruction. And by this time, there was a significant increase in the installed base of Unidata systems and software in universities. Many more universities started to take part in the Unidata network, and it was starting to have a real impact on education and research. So with the sponsorship from COMET, and at that time there was a national program to focus on mesoscale meteorology called STORM program, funded by NOAA, they were the key sponsors of this 1991 workshop that was attended by 80 people. So you now saw a more than doubling of the number of participants from the first workshop to the second workshop. And it had a format very similar to the first one, a combination of lectures, lab sessions, etc., held again up at the NCAR Mesa facility, as well as at the University of Colorado. Some people who attended that workshop called it a flea market because there was a lot of exchange of ideas, scripts for PC Mercatus, which was one of the software systems Unidata was distributing at that time. People exchanged instructional materials and curricular materials during that particular workshop, and hence the description of being a flea market. And Chuck Wash, who was the lead coordinator of that particular workshop and the head of the Unidata Users Committee, essentially spent the next year putting together a workshop report, the only full-length workshop report that was published from these Unidata users. It was a 241-page document that edited very much like a monograph or a volume from one of the scientific publishers. And that particular publication was commissioned by the NCAR Advanced Study Program, and you see the cover of that to the right. And I was pleased to contribute to that as one of the coordinators, because I had joined the Unidata Users Committee a couple of years before and was involved in the planning of that particular workshop. Here is a workshop group photo, that was taken at the University of Colorado. And there I am sitting at the far edge attending this workshop. I have to point that this was almost the who's who of synoptic meteorology or mesoscale meteorology at that time. You see at the center, Louis Uccellini, who is the director of the National Weather Service, Lance Bossart, who is the doyen and dean of synoptic meteorology in this country, Fred Carr, who retired as the department head at University of Oklahoma and was president of American Meteorological Society a couple of years ago, Dan Kaiser from University of Albany, and many others who were distinguished scientists in the field of mesoscale and synoptic meteorology. Let's fast forward 3 more years, and the third workshop also focused on the teaching of mesoscale meteorology in the era of modernized National Weather Service. By 1992-93, the National Weather Service Modernization Program was completed. And if you all remember, 1994 was the birth of the first web browser, Mosaic, that came out of the National Center for Supercomputing Applications, NCSA, at the University of Illinois, where I was working at that particular time. And when the first browser came on the scene, the World Wide Web took off. Essentially, people attribute the World Wide Web to that Mosaic browser, although the World Wide Web was invented by Tim Berners-Lee almost 3 years before. 1994 also saw, 94 also saw the launching of a new generation of geostationary satellites, and GOES 8 was launched into orbit in April of that particular year. And to bring all these data from NextRad, from profilers, from satellites, from new generation of satellites into Weather Service forecast offices, the National Weather Service and NOAA developed this advanced weather information processing system called AWIPS that was deployed in various forecast offices. Unfortunately, AWIPS was a proprietary system and could not be brought into a university setting at that time. Here is a group photo, and there were 72 attendees, and I'm the chessboard in the middle with the light and dark blue shirt. And we even had entertainment from the director of Unidata, who is truly a Renaissance man when it comes to his musical talents, and he performed for the workshop audience. The workshop was so energetic and engaged. The faculty were truly thrilled that they are now able to bring their class material to students via the World Wide Web. They saw the true value of these Unidata workshops, and they wanted to make sure that their department heads and chairs knew about that. So they actually passed a resolution during the workshop that is listed here and asked one of the leading synoptic meteorology professors to take that message and that resolution to the UCOR members meeting and the heads and chairs meeting that are held in conjunction, and make sure that the university heads and chairs knew about the importance of sending their faculty to these Unidata users workshop. And they also worked overtime and over a couple of after-supper meetings, drew a complete outline of 2 different courses, one focused on synoptic meteorology and one focused on mesoscale meteorology, and what should go into those, and how Unidata tools and systems should be brought in. You'll see the mention of GEMPAC, WXP, and Mercatus in there. They wanted to make sure that every topic had data used from Unidata systems and these tools essentially instructing students on mesoscale and synoptic meteorology topics. Moving on to 1997, by this time, there was sufficient capacity built in the community on the teaching of synoptic and mesoscale meteorology after the 3 workshops that were held. So the topics slowly started to shift in terms of emphasis, and the community that attended these workshops also was slowly broadening into other areas. And this particular workshop in 1997 focused on education, science education in general, but more importantly, education in atmospheric and earth sciences. Now you see no mention of mesoscale or synoptic meteorology. Now we are talking about atmospheric and earth sciences. And for the first time, Unidata Users Workshop invited speakers from quote-unquote education departments, not only from people in meteorology or atmospheric science departments. And Professor Tom Reeves from University of Georgia delivered a keynote speech on education in general, but the importance of mental models and the challenges we face in the society on scientific literacy. And he introduced his talk with this video. And with luck, I'll be able to play the video and get you to hear the audio. And this is worth listening. It's going to take a minute and a half or so, but it's well worth the time. Is there any audio?
Aaron Lee Fingerman, candidate in art.
This is Harvard commencement. Students are getting their diplomas.
Despite a lifetime of the very best education, students in our classrooms are failing to learn science. Many of these students will graduate from college with the same scientific misconceptions that they had on entering grade school. To test how a lifetime of education affects our understanding of science, we asked these recent graduates some simple questions in astronomy. Consider, for example, that the causes of the seasons is a topic taught in every standard curriculum.
Okay, I think the seasons happen because as the Earth travels around the sun, it gets nearer to the sun, which produces warmer weather, and gets farther away, which produces colder weather, and hence the season.
How hot it is or how cold it is at any given time of the year has to do with the closeness of the Earth to the sun during the seasonal periods.
The Earth goes around the sun, and it gets hotter when we get closer to the sun, and it gets colder when we get further away from the sun.
These graduates, like many of us, think of the Earth's orbit as a highly exaggerated ellipse, even though the Earth's orbit is very nearly circular, with distance producing virtually no effect on the seasons. We carry with us the strong, incorrect belief that changing distance is responsible for the seasons.
So there you have it. That's the challenge with science literacy and mental models, because people have learned over and over again that seasons and the temperature variation between seasons is a result of being closer versus being further away from the sun. How many of you believe in that? So, and these are Harvard graduates. So there you can see the many challenges our science education field faced then and still faces today. Some of the workshop highlights included the creation of HTML documents. Our lab sessions focused on the attendees actually creating HTML documents with both text and visual information, graphics or photos or other pieces of text and other tables. And the faculty truly felt they were empowered now, to use a new medium for communicating and distributing course material. The sentiments of this particular workshop were best exemplified by this participant's comment. I applaud this effort in bringing research, teaching, technology into one workshop. We need much more of this. It forced me to reevaluate my teaching. Moving 3 years forward, the 2000 workshop title was Shaping the Future, Unidata Users as Leaders. So the focus was shifting from synoptic, mesoscale education to being leaders in the field. And at the same time, Unidata made a conscious effort to go beyond meteorology and into Earth system science and multidisciplinary science. Tim Colleen, who had just started as director of NCAR at that time, was one of the keynote speakers, and he came from University of Michigan, where he had created many interdisciplinary courses and programs, and he argued that interdisciplinary Earth system science courses could revolutionize undergraduate general education. The workshop attendees, who still came largely from meteorology or atmospheric science programs, expressed some concern that expansion into Earth system science could result in decrease in focus on the core meteorology community that Unidata was serving from the beginning of the program. clearly there was some risk, although the history would bear that that risk was somewhat, that concern was unfounded, because Unidata has managed to serve the core community while also providing capabilities that will advance the broader Earth system science community. In the 2000 workshop, Unidata also introduced a new tool that was beginning to come online. It was not fully developed at that time, and that tool was the Integrated Data Viewer, which at that time was called MedApps Toolkit, which was essentially a collection of individual tools revolved around a core foundation and library. And this particular tool was based on an architecture and software built by Bill Hibbett at University of Wisconsin Space Science Engineering Center called WizAD. That's the architecture on which MedApps and IDV were built. And here is Bill Hibbett giving a presentation on that tool. And the result was the MedApps and IDV tool, which now provided meteorology students and faculty the ability to visualize the atmosphere in 3 dimensions using real-time weather data. Until then, there was really no tool that brought all of the meteorological observations, data, and model output into a 3D visualization environment prior to the release of the IDV. Here is just a collage. Linda Miller was one of the coordinators and has been the coordinator for these workshops for almost 20 years until her retirement about 4 years ago. And here is also a group shot, and the workshop attendees were challenged to go up and hike the Mallory Caves behind the NCAR lab, which some of the students took, and here they are working their way up the rocks, to get to the Mallory Caves at the top. And just to prove that I was at this workshop, there is a shot of me next to Linda at the picnic that was held up at Green Mountain, at the top of the foothills as part of the workshop activities. In 2003, the topic shifted to expanding horizons using environmental data and model output in education, prediction, and most importantly, decision making. So there was a thrust to move from just education and research into also decision making and making weather, climate, and other kinds of data useful for society beyond just making those forecasts. This workshop coincided with the roughly 20th anniversary of the program, so there were celebratory activities in conjunction with the 20th. And this was the first workshop I oversaw as director of Unidata. So you can imagine the nervous moments I had to make sure that everything goes off without a hitch. And the workshop laid out a vision for Unidata's future in the broader geosciences beyond just academia, particularly education and research. And this particular workshop expanded the emphasis of the workshop into geographic information systems and how geographic information systems and the data and software systems used in meteorology or atmospheric sciences could be integrated or coupled. Here is Sam Williamson, who was at that time the federal coordinator for meteorology, which is an interagency activity led by the Office of Science and Technology Policy in Washington, giving a talk on public policy and use of weather and meteorological data in public policy. So he was one of the invited keynote speakers at this workshop. And we also had, during the workshop, one of the things that we started doing, and that is meet the developers. So there were stations set up to meet all of the developers. Here is Don Murray, Jeff McWhorter, and Stu were talking about the IDV tool, which was released as V1 just a few months before this workshop. And there were stations set up for LDM and threads as well at that particular workshop. And in my talk at that particular workshop, I showed this particular slide as an archetypical example of the importance of expanding our thinking beyond meteorology and meteorological system to integrate data from multiple disciplines as well as GIS. And a few months earlier, Tropical Storm Allison dumped close to 40 inches near Houston. You can imagine the amount of devastation that it caused. But to study this kind of a phenomena, you have to bring data from meteorology, you have to bring data from hydrology, you have to bring data from oceanography, you have to bring geographic and information system data to understand how to evacuate people, how to provide, where the schools will be closed, all those things. This is what I mean by decision making associated with a catastrophic event such as this particular tropical storm. And Ben Domenico, who was the deputy director of Unidata at the time, gave a talk on threads, which was an emerging tool that Unidata was developing. Prior to this particular time, threads was viewed as a cataloging and discovery tool. But as we started working on this project, we recognized that it needs to go beyond being a cataloging and discovery tool, as well as providing data via multiple APIs and access methods for geographic information systems. And you can see that the threads servers API for WMS and WCS were thought through at that time and were subsequently implemented. I'm pleased to say that today we have a very large community accessing data through those APIs beyond just NetCDF API or traditional OpenDAP API. And Ben also showed how the GIS tools should interoperate with scientific information systems as well. And here is Olga Williamy giving a talk on GIS, because NCAR had started a major GIS program within the National Center. Subsequent to this workshop, Unidata worked with Esri to provide native support for NetCDF. And today, ARC clients all over the world are able to take advantage of model output from various operational and research models that write out data in NetCDF from ARC servers. This also helped Unidata broaden its community even more, because we now had a lot of GIS people with whom we didn't have as good a relationship as a community of meteorology programs until then. Moving on to 2006, the focus shifted to the use of models in atmospheric and related science. And this was the workshop that was held because many faculty were slowly beginning to use toy models, simplified models like barotropic models or other kinds of single sounding models, and many other types of educational models such as TELA and EdGCM or Education GCM, and we're bringing them into their teaching. There were 80 participants who were introduced to various things. And at this time, this is almost a dozen years since the beginning of the World Wide Web, many groups had created applets, Java applets, that demonstrate very simple simulation or activities. So you could think of them as models as well. And they were introduced. And also a very ambitious program called LEAD was making available the WRF model online to be run by any user using supercomputing facilities and the TeraGrid. And this was also the workshop that set aside funds for students to participate. So we invited students to apply and received many applicants. And we selected, close to 9 students, I believe, at the end. And here are 7 of them taking a hike up at the mesa and doing a photo, group photo. I don't know where the other 2 went that day, but they are not to be seen in this particular photo. And there on the far right is a dude called Sean Arms, who attended from University of Oklahoma. These students were given $200 by John Snow, who gave a talk on Stella and the use of Stella in classroom. John Snow was the dean at University of Oklahoma for many years. And he gave them $200 to go have a good time up at Pole Street and get together and talk about issues that are important to them. And they came back the next day and met with me and the NSF program director for Unidata at a lunch table and said, we have an idea. We don't know much about Unidata among students. To increase awareness, can you invite one of the students to be a representative at the Unidata Users Committee, and they can be the buffer or interface between the Unidata program, its governance, and the student community. And we thought it was a great idea. And after many nominations, Sean was picked as the student representative. And again, as they say, the rest is history. We have had a student representative ever since, and we now have one of them attending here, Kim, at this particular workshop. The addition of students on our governance has been one of the best things that has happened to Unidata governance in quite some time. Here is just a collage and the group photo, the obligatory group photo, and at the far left bottom, you are looking at the lead workshop being held in conjunction with this particular users workshop. By 2009, the Users Committee recognized that we have spent a lot of time on observations and other things like models and science education. We need to come back to some of the observational things that are happening in the atmospheric science space. And they chose the theme of operational and experimental observations in geoscience education, and how to use instruments and observations in geoscience education beyond operational systems. There were 81 participants, and this was the workshop where the then Unidata tool, Ramada, was introduced to the community for the first time. So the workshop material for archiving and sharing amongst all of the participants made use of this particular tool. And you can, to this day, go back to that workshop repository and find all of the information that was shared at this particular workshop. Since then, Ramada has moved out of the program as a core Unidata developed tool into the private sector. Here is just a group photo, and you'll see that we actually, in addition to having traditional instruments, we actually had a rotating tank at the far left that Brian Tang from MIT presented at this. And we had students launch balloons in real time. For this particular workshop, they were staying a little bit farther away from Center Green, so many of them were able to take bikes, from the hotel or from here and go back and forth as needed. We also took a field trip in this particular workshop, literally down the road at that time, because radiometrics was located next to Boulder Beer, just at the other end of Center Green. And what you see there, like that post box, your mailbox, is actually a radiometer. It's a Radioson type instrument that uses microwave signal to get thermal soundings and moisture profile. And that was built by, and it's still being built, and now they have users all over the world installing these. They have since moved out of this particular area into Gun Barrel, where now they have, because they grew much bigger than what their facility accommodated here. We also brought in NCAR's Earth Observing Lab's integrated sounding system with the wind profiler and co-located balloon launching facility. And that year also coincided with Unidata's 25th anniversary. So we did cut a cake. The next workshop focused on navigating Earth system science data of many different kinds. It had record attendance. Until then, the attendance was hovering around 75, 80 or so, and here it popped over 100 because the topic was much more broader and we had participants from federal agencies. We had lots of participants from the private sector at this particular meeting, international institutions as well, and many geoscience and computer science domains. So Unidata workshops were starting to attract people from computer science programs as well. And the participants were wowed by two speakers, Johnny Lin and Daryl Hertzman, when they introduced the interactive Python notebook. That still remains a very revolutionary tool. And people thought, wow, this is so cool how we can program, and develop our tools and software using IPython notebook approach because it was relatively new to majority of our users. NSF had unveiled the EarthCube initiative just the year before, and the program director for NSF, for EarthCube at NSF at that time, Cliff Jacobs, who was also the program director for Unidata for more than 20 years prior, presented the EarthCube program and its vision to the workshop audience. Many other related topics on data friction, geoscience at the speed of thought, tools for fulfilling NSF data management plan requirements, etc. were also some of the foci. And here is a collage. Here is Daryl presenting the IPython notebook presentation. And if you read carefully, he actually asked everyone to install mthought, which is required to run IPython notebook at that time. And students were actually, working with him in concert with his presentation to write their code and test them in real time. So that was a really cool thing. The students were all asked to give poster presentations as a quid pro quo for, underwriting their participation at the workshop, and they all did an excellent job of presenting their work at the workshop during a poster session, and I look forward to this afternoon's poster session when the students will be doing the same. You have the obligatory group photo and the discussion that took place on topics related to the crisis we face in science education in this country. And there you have Cliff Jacobs and Linda at the reception. This was the last workshop Linda Miller coordinated on behalf of the Unidata staff. And Josh Hang, our community services manager, has been playing that role since then. The 2015 workshop focused on data-driven geoscience. It was a pretty ambitious program with had a grand title of Applications, Opportunities, Trends, and Challenges. It talked about not only Python, but also the first introduction of cloud computing to the Unidata workshop audience, because by that time, Unidata was starting to develop tools and capabilities for transitioning our data systems and products and services to the cloud. Big data was another important topic that got discussed, and continued emphasis on data management plans, particularly for fulfilling long-tail scientist needs, how individual PIs can publish the results of their science, the results of their research. There were 75 participants, including 10 students, and the workshop audience made a general recommendation to consider using Python as a primary programming language for our community as well as for Unidata. And subsequent to this particular workshop, Unidata invested and is continuing to invest a significant amount of resources in developing our Python capacity and our Python tools. The workshop, Unidata workshops, for the first time, you took advantage of GitHub for sharing people's code that people developed during the workshop. And GitHub was relatively new as an open source collaboratory environment for our community. And the workshop participants also recommended that Unidata create more virtual machines of its applications. We actually handed out virtual machine at this particular workshop for people to take back of some of the tools that Unidata has developed. And at that time, Docker was new on the scene, and Unidata decided to use Docker as the basis for virtualizing our applications. And this is an area where progress was made more rapidly than people normally envision. Unidata was able to containerize and use Docker for virtualizing almost all of our applications except one or two. So we have a suite of Docker images and containers available for people to download and use in their own setting. And we use them in our own shop as well. And these are made available through our GitHub repository. Here is a group photo of the three student reps on the Unidata Users Committee. Kim on the far right, Stefan Saselski in the middle, and Sean Arms. They were together at this workshop, and we took a photo of them. And here is Ryan giving help to workshop attendees on the use of Python and Python tools. And one of the most exciting presentations at this workshop was given by this former student and student member of our users committee, Stefan Saselski, who actually created in real-time instance of Unidata systems, or this work he was doing on the Amazon cloud. And he was able to spin up an instance in real time, run the WRF model in real time, all while the workshop audience was watching him, and he was standing on the stage doing this. And we also learned some new things at the workshop in terms of he went to China to bid on the Amazon time because it was cheaper at China where it was nighttime versus buying time on the Amazon AWS in Oregon or in Virginia. So this was all very new concept to the Unidata workshop participants. And we also had a panel session at the end on where Unidata and the community are moving. And that brings me to this particular workshop. I'm not going to spend much time because Kevin has laid out a wonderful introduction to what's going to happen over the next 4 days. And theme, as you all know, is reducing time to science, evolving workflows for geoscience education, and the topics are listed here that Kevin has already shown. But let me just take a couple of minutes to talk about where we are going next. As Bill Coe mentioned, and I wish he had not preempted my introduction of this, but we are in the midst of developing our 5-year proposal that we will be submitting in September. And for this 5-year proposal, we would like to hear what some of the things in your area that you need Unidata's help in. As always, our proposal will continue to address the evolving and newly emerging needs of our education and research users. Our focus on data proximate analysis in the cloud will, of course, continue because the work is still ongoing and is not finished. but it will be expanded and will include additional goals, including scalability and efficiency of Unidata systems and tools in the cloud, how Unidata data servers, such as Threads data server, can be deployed and can read data directly from object store on Amazon or other cloud platforms, how Threads and our other tools can expand to larger and larger data sets and volumes. Significant leveraging of Jupyter Hub and Python ecosystem will continue because Jupyter Hub is that clue that allows you to do data approximate and analysis in the cloud very efficiently and effectively. We will expand our activities in collaborative open source development and bring more things into GitHub and want to work with a worldwide community of developers in developing our tools and resources. And you're already seeing, that in full swing with our MetPy effort. We want to expand beyond Unidata being just a server farm or facility where you can download data and software, but also we want to explore workspaces and modern workflows running on workbenches implemented through a cloud-hosted science gateway. Unidata, about 6 months ago, opened up a science gateway on the Exceed Jetstream cloud platform, and at the moment it's a resource, much like Motherload at UCAR or our GitHub software repository. But we want to go beyond that and create workspaces for our community and explore where we can actually, and the community can collaborate amongst each other, share their software, tools, results, etc., through these workspaces with one another. So we want the collaborative aspects and community building aspects of the Science Gateway to flourish as well. We want to make sure that the Unidata systems get coupled with the high-performance computing systems and state-of-the-art prediction models. So we want to facilitate an end-to-end ecosystem for doing modeling research in the cloud and tie our future activities to NSF's direction, particularly the goals of the harnessing the data revolution, one of NSF's 10 big ideas. You'll see the other 9 shortly. And facilitating the conduct of open science and reproducibility. This is an important topic for all of science and society. And we need to make sure that our science is open and our science is reproducible. And our thrust to moving toward these cloud efforts and the use of Jupyter Hub Notebook and other things are to ensure that reproducibility can be addressed in a very serious way. We need to make sure that Unidata's future is somewhat aligned with the directions at NSF. And NSF last year unveiled these 10 big ideas, one of which is harnessing the data revolution. And there are a few others that are related to Unidata, including navigating the new Arctic and addressing challenges in the polar sciences or in Arctic sciences. So we will be making sure that what we do is of benefit to the National Science Foundation PIs as well. And that brings me to my final slide, or last to the final slide. These workshops, as I've said at the outset, have provided an important forum for addressing contemporary issues to enhance, teaching in the atmospheric and related sciences, and have facilitated sharing of ideas, materials, in-depth discussion on curricular matters, and offered real-world solutions to improve student learning. And I want to thank the Users Committee for the close collaboration we have had over the past 30 years in making these workshops not only happen, but a real success and of benefit to the attendees. And that collaboration has been one of the key reasons for the success. And you all have seen how the topics have evolved, because they evolved as science evolved in our field, and the trends and techniques evolved not only in information and computer technologies, but in other areas as well. And with that evolution came the demographics of participants. The first couple of photos I showed you had synoptic meteorologists exclusively at the table. And if anything, they are in the minority today, a distinct minority, I might add, because we have users from many organizations, many different domains, many parts of the world, and as well as many types of organizations, such as the private sector and the agency people. And they have had a lasting and close, lasting and strong impact in advancing science education in our country. And we always do these post-workshop surveys on the last day, and almost all of them have overwhelmingly indicated that these workshops have had a positive impact on the participants, and they have impacted their own teaching back at their institution or student learning. And I would be remiss if I didn't acknowledge the users committee, the organizers, Kevin, Victor, and John, and all of the Unidata staff for a well-planned workshop. And NSF did give us additional funds to hold this workshop, so I have to thank the National Science Foundation as well, and their overall sponsorship of the program for the past 34 years. Thank you.